Now that we've covered a lot of our secondary structural elements, we're ready to talk about tertiary structure. And to recall that secondary structure, remember, is local interactions between neighboring amino acids, the hydrogen bonds that we saw forming within alpha helices and beta sheets. But tertiary structures, that's all about the global interactions. That is, the distant R groups coming together, maybe an R group from over on one region of the protein folding in 3D space to come near and interact with perhaps another region within the larger polypeptide chain. And these interactions, again, are between R groups rather than between the hydrogen bonds that we saw between backbone structures in secondary elements. In tertiary structure, we see the R groups interacting in some way, and predominantly these interactions tend to be hydrophobic. However, occasionally they are even covalent. Think about, for example, disulfide bonds that can form between cysteine residues that perhaps were not near to one another at all in primary sequence, but in tertiary overall 3D structure, they may have come close to one another and are able to now form that covalent disulfide bond. So that's considered also a structure that is part of the tertiary or three-dimensional structure. What's really interesting is that within 3D space, we tend to see these reoccurring themes in protein folding. And these themes are often ways in which an alpha helix orients with respect to a beta sheet or a strand. And we get these reoccurrently happening. This has a sexy-minded term. It's called folding motifs, or maybe even sexier, supersecondary structures, because they're things that tend to reoccur consistently and are often associated with some sort of function in the greater protein. They're recognizable combinations of alpha helices and beta strands and loops that tend to reoccurrently reappear. And so we see this, we've actually already investigated one of these folding motifs or supersecondary structures. We talked about the coiled coil. Recall how that had two alpha helices that would wrap around one another, and that the function that tended to be associated with that supersecondary structure was the binding of DNA. We see other folding motifs like that. For example, one of the common ones that reoccurs is actually called the helix loop helix. So you might get that, right? I've got a little model here, but obviously this is something that looks like this, where you've got an alpha helix, then you've got a loop that connects it to a second alpha helix. And it's interesting because this particular structure tends to be associated with a function as well. In fact, many times these are calcium binding proteins. And check out what kinds of reoccurring motifs we might get. I've already started by drawing the helix loop helix right here, so let's just label that as helix loop helix. And remember then that this is often associated with with a calcium binding proteins. There are some DNA binding proteins that like this too, but they're more likely to be helix turn helix. But most often associated with calcium binding proteins. Calcium 2+, right, a calcium ion, a cation, calcium 2+ binding proteins. So I want you to think for a minute then, what does that mean about the types of amino acids that we might see in this particular protein? If it's binding calcium, what kind of amino acids would be likely to interact electrostatically or ionically with a calcium 2+ cation? How about these two? Glutamate and aspartate, so that you do see within these motifs glutamate and aspartate that are acidic amino acids that can interact with the calcium cation, so they carry a negative charge, so that's a nice love-love interaction that goes on there. So one motif then is the helix loop helix. Let's look at another one. This one is actually called the beta alpha beta motif. So we've got a beta strand and then a loop that connects it to an alpha helix, and then a loop, and then another beta strand. So this is termed the beta alpha beta. See if I can get my arrow on there. So the beta alpha beta unit or structural motif. Cool. Let's look at another one. This one was named, gosh, talk about a sexy mind. Whoever named this had a sexy mind. This is called the Greek key. And it's named that because of the fact that it looks a lot like a reoccurring design that's seen on Greek pottery. And what's interesting about it is that it is an anti-parallel beta sheet. But what happens in it is that the first two strands in this beta sheet are in the center, and then the third and fourth strand are actually on the outside. And so it makes what's called the Greek key. So this is strand, and let me just get another color pen. This is strand 1, 2, 3, and 4. So 3 and 4 are the flanking strands, and 1 and 2 are in the center. So interesting, different recurring motifs that are seen, or aka supersecondary structures that we see in proteins.